There are billions of stars in our universe. The diversity of each star is as unique as every human on Earth. From extremely hot blue stars to cooler red giants, and of course, even our own sun. It is quite a process for the formation or birth of a star, and their lives are quite similar to ours, except of course that stars live much longer than we do. So how do stars form? Star birth is an extremely long, drawn-out process. It is not a race. Stars come from giant gas and dust clouds which span many light years all across the universe. These clouds are called nebulae, and they can be very brilliant eye candy. The word nebula comes from the Latin word for cloud, and they can span from millions of miles to hundreds of light years. The dust and elements found in these clouds are what eventually form into suns all across the universe. But before we look at how stars are formed, let's take a moment to revel at the beauty of nebulae. Wait, was that a horse floating in the middle of space? Well, it sure looks like a horse. This is the Horsehead Nebula, one of the most famous dust clouds ever pictured in space. It is in a category of nebula called dark nebula. There are 5 categories of nebulae found in the universe. All of these categories have to do with the way each is illuminated. The first type of nebula is emission nebula. These are hydrogen-heavy gas clouds which the name suggests emit light from within them. An emission nebula contains one or more stars which give off plenty of radiation. This excites the elements found in the dust cloud, which is mostly hydrogen, and causes them to emit brilliant shades of mostly red light. A few examples of emission nebula are pictured here. The Orion Nebula, one of the largest and most beautiful emission nebula in the universe. Another example is the ruby red Pelican Nebula. See if you can spot the outline of the bird. Another type of nebula is a reflection nebula. These clouds reflect light from nearby stars outside of their realm. Reflection nebula are very active in creating new stars. An example is shown here. Another very popular reflection nebula is the group of 7 sisters known as the Pleiades. You can see the bright blue light being reflected by the gas cloud from the cluster of stars surrounding it. In nebula such as the Horsehead, light from stars behind the dust cloud is blocked, causing large black spots to be seen throughout the cloud. As seen by this picture, the horse's head is clearly blocking light behind it, causing the outer edges of the head to glow. When viewed in infrared light, the Horsehead Nebula can be seen as a cloud and not just a dark spot. Planetary nebula and supernova remnants make up the last 2 categories of nebulae. These are usually much smaller than the previously shown nebula and are formed from other stars' remains. Planetary nebula get their name simply from their shape, in that they look like a bright planet. These clouds are formed when a star emits a large chunk of itself, which is blown away and collected into a small nebula of gas. Supernova remnants are the remains of a star after it explodes via supernova. They remain very hot and bright for years after the star's explosion, but eventually cool enough to begin forming new stars just like any other nebulae. Take this nebula, for example. Most of the time, it remains dormant and uneventful. Now at some point, a star or other large source of energy may pass near or through the cloud. Maybe a supernova occurs, and the blast pushes particles of dust in the cloud closer together. Eventually, a big enough clump is formed into the beginning stage of a star, called a protostar. The protostar compacts, pressure builds up, and the clump increases in temperature dramatically over a long period of time. Sometimes it's not meant to be, and the clump is just unable to heat up enough to become a star. This is the case of a brown dwarf, a lifeless clump of cool clutter. However, if the pressure and temperature is great enough, the protostar will begin nuclear fusion, the process by which stars create energy. When nuclear fusion begins, the breath of life is blown into the clump and the star's life begins.